We are from group 5. This is our group member. First is me, ROSMILAH binti HAMID, JUHAIRAH binti JUHAN, MARIAMAH binti ASIS, AINNA IZZWA binti MAHAT, SYAMIMI NADHIRAH binti RUSLI, FATIHAH binti BISRI, and last, MOHAMMAD RAIHAN SHARUL bin SARON. Next, I will explain about descriptive and summary of statistics. Descriptive statistics are brief informational coefficients that summarize a given data set, which can be either a representation of the entire population or a sample of a population, while data is a statement or a collection of collect information observation. We are given a card type data set with 150 observations for this task, so we decide to randomly select 150 of the 392 cases based on the lowest metric number of our group members. In addition, the data set has two types of variables, which are qualitative and quantitative. We choose quantitative variables because this variable can perform algebra operations such as addition, subtraction, multiplication, and division. Therefore, we choose from the given dataset A is liter per 100, week, and horsepower. And this is the variable used. Among them is liter per 100, kPl, cylinder, horsepower, week, and the last brand.
Hello, my name is Muhammad RAIHAN SHARUL bin SARON. Today I will present about sampling data and record categorical data. The first table is for the categorical data. Table 1 shows that Honda and BMW is 26.7% has the largest percentage, followed by Ford, Mercedes, Audi, Opel, Citroen, and the last one is Datsun. Table 2 shows that the numerical data for LP100, the highest class interval is the third class interval, which is 31.3%, and the lowest class interval is the eighth class interval, which is only 7%. The table 3 shows the numerical data for horsepower. The highest class interval is on fourth class interval, which is 29.3%, and the lowest class interval is on the 7th and 8th class interval, which is only 4%. The table 4 shows that the numerical data for weight, the highest class interval is on the first class interval, which is 19.3%, and the lowest class interval is on the 7th class interval, which is 3.3%.
So I will continue the next part, which is the 3.0, that is numerical descriptive measures that have 3 main points of measures. Firstly is measures of central tendency that have including mean, median, and mode. The second measure is the measures of positions, and the last measure is the measures of variance. The first is the measures of central tendency, which is the mean. The formula of the mean is mean equal to total of fx divided by n. So the mean for liters per 100 is 6.28. Next, I'm going to explain the second measures of central tendency, which is the median. The formula of median is Lm plus n divided by 2 minus total of Fm minus 1 divided by Fm multiplied by C. So the median of liters per 100 is 6.15. The last measures of central tendency is the mode. The formula of the mode is Lm equal to change 1 divided by change 1 plus change 2 multiplied by C. So the mode of liter per 100 is 5.64. Then I'm going to explain the second measures, which is the measures of position that have divided by 2 parts, which is the first quartile and the third quartile. The formula for the first quartile is LQ1 plus F divided by FQ1 multiplied by C. And the first quartile for liter per 100 is 5.25. While the formula for the third quartile is LQ3 plus 3N divided by 2 minus F divided by FQ3 multiplied by C. And the third quartile for liter per 100 is 7.17. So the interquartile range of third quartile and the first quartile is 1.92. The last measure is the measures of variance. The formula of variance is S power of 2 equal to 1 divided by 150 minus 1 multiply total of fx power of 2 minus total fx in bracket and the power of 2 divided by n. So the variance of the liter per 100 is 1.90. The formula of standard deviations is S equal to source of power as the power of 2, and the standard deviation for liter per 100 is 1.39. Next, I'm going to explain the horsepower measures, which is the mean is 1.34, the median is 1.29, and the mode of the horsepower is 1.35. While the first quartile of horsepower is 0.92 and the third quartile is 1.49, while the interquartile range is 0.57, and the last is variance of horsepower, which is 0.14, and the standard deviation of horsepower is 0.37.
Next, I will explain about measure of central tendency, measure of position, and the measure of variation of width. The measure of central tendency has three, which is mean, median, and mode. The mean of width is 3.82, median 3.74, and the last one is mode 3.21. Measure of position: quartile 1 3.61, quartile 3 4.19, interquartile range 0.58. Measure of variation: variance 0.28, standard deviation 0.53. Graphical presentation. First is histogram. From the histogram, we can see that the graph is labeled as the x-axis with the center point being so that the graph starts in the first class with the midpoint at 3.16, where the frequency is 7, and ends up in the last class with the midpoint 0.65, where the frequency is 1. Therefore, we can conclude that the highest level of liter per 100 in a car is between 4.77 to 5.83 because it is the highest frequency compared to other car brands. Liter per 100. From the graph line, we can see that the graph is labeled as the x-axis with the center point being so that the graph starts in the first class with the midpoint at 3.16, where the frequency is 7, and ends up in the last class with the midpoint 10.65, where the frequency is 1. Therefore, we can conclude that the highest level of liter per 100 in a car is between 4.77 to 5.83 because it is the highest frequency compared to other car brands.
Hi, Assalamualaikum. My name is IZZWA. I would like to continue this presentation, which is bar chart for horsepower. From the bar chart, we can see that the graph is labeled x-axis with the midpoint, so that the graph starts in the first class with the midpoint at 0.77, where the frequency is 14, and ends in the last class with the midpoint 2.24, where the frequency is 6. Therefore, we can conclude that the highest horsepower found in cars in each brand is between 1.30 to 1.50 because it is the highest frequency compared to some other car brands. Next is histogram for weight. From the histogram, we can see that the graph is labeled as the x-axis with the center point being so that the graph starts in the first class with the midpoint at 3.12, where the frequency is 29, and end up in the last class with the midpoint at 5.22, where the frequency is 1. Therefore, we can conclude that the highest level of weight in car is between 2.965 to 3.265 because it is the highest frequency compared to other car brands. Next one is frequency polygon for weight. From the frequency polygon, we can see that the graph is labeled as the x-axis with the center point being so that the graph starts in the first class with the midpoint at 3.12, where the frequency is 29, and end up in the last class with the midpoint at 5.22, where the frequency is 1. Therefore, we can conclude that the highest level of weight in a car between 2.695 to 3.265 because it is the highest frequency compared to other car brands. The last one is pie chart. From the pie chart, we can see the percentage slice for the class interval 5.0272 to 5.372 is the smallest from the others because that the class is the lowest frequency compared to the other class, which only recorded 0.7%. The percentage slice for the class interval 4.169 to 469 record the largest percentage from the others because that class has the highest weight, the percentage compared to other brands. That's all from me. Thank you.
This is numerical descriptive measures that have mean, median, mode, standard deviation, variance, range, minimum and maximum, sum and percentiles for LP100, HP and also weight.
Assalamualaikum, my name is Nur Fatihah binti BISRI and my matrix card number is A21A2831. We go into the part of hypothesis testing. Based on the table above, show the various of variable. There is liter proof, weight, and horsepower. The DF in 149 that mean no changes in DF. In mean differences also no changes, but at the lower and upper for LP100 is 4.1214 and horsepower is 3.9829. Now for the calculations, step 1, H9 MU1 minus MU2 equal to 0, H10 MU1 minus MU2 equal to 0. Step 2, significant level alpha equal to 0.05 and step 3, using t-test. In test testing, we got t equal to 1.1. In step 4, fail to reject H9 and step 5 decision, this no reject H9 and we can conclude that the two sample means are equal or there is no significant difference between the two sample means. Next part is ANOVA. So the factor that we're choosing is species. The p-value the ANOVA is less than 0.01, which means at least 1 for 3 variable is liter per 100, horsepower and weight. For the calculation for decision rules is FFA V1 V2, which means reject H9 is FF 0.05, 7.142 to 2.629 more than 3.7854. So there are no significant differences among the treatment.
Assalamualaikum. My name is SYAMIMI NADHIRAH binti RUSLI. My metric number is 818289. Next part is correlation analysis. Correlation is a statistical technique used to determine the degree to which two variables are related. Explanation from table. The value of R between LP100 and HP 0.731 in which shows the strong positive correlation. R value LP100 and weight is 0.712 in which shows the strong positive correlation. The value R between HP and weight is 0.719 is shows the strong negative correlation.
So we go into the part of coffee interval. The mean for liter per 100 group is 3.9133, the upper bound is 4.1214 and the lowest bound is 3.7052. The differences between upper and lower is 0.4162. The mean for the horsepower group is 3.6933. The upper bound is 3.9829 and the lower bound is 3.4038. The differences between upper and lower is 0.5791. The mean for weight group is 3.3467. The upper bound is 3.6326 and the lower bound is 3.0607. The differences upper and lower is 0.5719.
Next part is prediction modeling. Figure above the shows the association between liter per 100 horsepower and weight. There is a high-level association between liter per 100 and horsepower, liter per 100 and weight, horsepower and weight. Among an independent variable, there is high-level association between liter per 100 and horsepower. Then, explanation from correlations table is liter per 100 correlates with horsepower and weight. There is no significant correlation between liter per 100 with horsepower and weight. Horsepower correlates highly with liter per 100 and weight. There are no significant correlations between horsepower with liter per 100 and weight. Weight correlates highly with liter per 100 and horsepower. There are no significant between weight with liter per 100 and horsepower.
The conclusion is the data provided in set A show the liter per 100, KPL, cylinder, horsepower, weight, and brand. SPSS Statistic is an IBM statistical software suite for data management, advanced analytics, multivariate analysis, business intelligence, and criminal investigation. IBM SPSS Statistic to randomly record 150 observations from a given data file. In the presence of a table, we parse the data set using variance, numerical, descriptive measures such as measure of center tendency, measure of position, and measure of variation. That's all from our group. Thank you.